So the central limit theorem tells us that for a population with any distribution shape, the distribution of the sample means approaches a normal distribution as the sample size increases. The main condition of this theorem is that the samples have to be simple random samples. So here's some points from the central limit theorem. First of all, the mean of the sample means is going to be the same as the population mean. So in other words, our expected value for our sample means is going to be our population mean. So this is the easiest formula you'll see in this class because all you have to do is say what was the population mean. You don't have to do anything to the number, you just write it down. For the standard deviation of the sample means, this one you have to do a little bit with. The standard deviation decreases as n increases. And how we actually get it, this is our standard deviation for the sample means. You take your original population standard deviation and divide it by the square root of the sample size. So you can see looking at this formula that as n gets bigger, that means you're dividing by a bigger number, which would make this overall value smaller. Okay, another point from the theorem is that if the original population is normally distributed, then for any sample size n, the sample means will also be normally distributed. So if the original population had a normal distribution, we don't even have to worry about what sample size we have. Our sampling distribution will be a normal distribution. Now if the original population is not normally distributed, then we do have to think about the sample size. In that case, we have to look at samples size larger than 30. If they are larger than 30, then the distribution of our sample means is going to be approximately normal. If they're smaller than 30, then we don't have any guarantee of anything. All right, here's another example. This was a population that had a normal distribution to start with. So here was the distribution of our sample means when our sample size was 1. And you can see that even this one looks approximately bell-shaped. When n is equal to 10, we get an even nicer little bell shape. And when n is equal to 50, then we have even more of a bell shape for our sample mean. Now this one comes from a uniform distribution where every value has the same probability. So here was when n equals 1. This is what the distribution looks like for the sample means. When n is a little bit bigger, when it's 10, then we're getting a little bit closer to being a bell-shaped curve. When n equals 50, we have a pretty good approximation of a normal distribution. In other words, this is pretty close to being a bell-shaped curve. And finally, what if we start out with a sort of a U-shaped distribution, where it's higher on the two ends and lower in the middle? Still, when n is equal to 10, it's already gone to a somewhat bell-shaped distribution, and when we go all the way to n equals 50, we've got a nice bell-shaped curve.